Okay, last day we were discussing about the new topic, which is internet and its services, internet. And actually we couldn't do our workbook. So I'm thinking of finishing the workbook part today and start and go back to the internet email lesson. Right, then the first thing which is there in your workbook, that is physical computing 5.1. So it's asking about the outputs for the given circuits, given logic circuits. You have to decide what is the output in the given circuit. So let's try this. I think you can remember the logic behind the AND gate and OR gate and NOT gate. So basically AND gate is output, and AND gate outputs 1 when all inputs are 1. OR gate output 0 when all inputs are 0. NOT gate will invert, right? Here, so considering the logic, AND gate will output 1 if all are 1, but all are not 1. So therefore this is 1 or 0?
0.
0, right? If you get 0, NOT gate will invert that, right?
1.
Right? That will be inverted to 1. Okay, the next one, can you try? 0, 0 will be
1.
0 will become 1. Then you have AND gate. If both inputs are yes,
1.
it's 1.
1.
Both inputs are 1, and gate will output 1. So then that will be inverted back to the
0.
Okay. So the next thing is 1, 0. Since this is AND gate, if both are 1, only 1, otherwise it's 0. 1 will become 0 here because of the NOT gate. If both are 0, OR gate will output 0, and that will be inverted back to the 1. Okay. Is it clear to you or difficult?
Clear, sir.
Others? Is there any difficulty?
Yes, sir.
Right. Let's move to the next one then. So if you are using two devices, please mute your microphone in one device. Otherwise, like it will be echoing, right? It's generating echo. Okay. Then the next one. So it's about the multimedia logic software. So you have the toggle palette in the right side and the window in the middle, menu bar and the toolbar in the top. So when you install this, actually this is supported for Windows versions. So what you should know in your level is the first one, selector, wires and the nodes, AND gate, OR gate, NOT gate. Those are the basic 3 gates. Then you have LED here. This is actually 8 segments. We are not going to discuss about that in grade 8. Here XOR gate, that's also not under discussion in grade 8. Buzzer is basically issuing one sound. Switch, that is the input, and text you can use to label, right? Okay, so let's see what's there in the software. I would like to give you a chance to share your screen. So anyone who has installed the software, can you share the screen? Please quickly share the screen because we have to do a lot today. Today will be like a lot of practicals after this. Let me. Someone who has installed, can you share multimedia logic? Yes, someone who has installed multimedia logic. No one. Right, okay, then I'll go back to the thing because I asked you to install multimedia logic, Pute. If you have installed, okay, Aditi, thank you. But this is logic, multimedia logic, very small software. Okay, let's draw a small diagram using, okay, can we use AND gate? Can you use AND gate? Okay, let's create 3 input AND gates using 2 AND gates. Yeah, you can draw that. Okay, draw another AND gate, put it. AND gate, 2 AND gates. I just want to draw 2 AND gates. Okay. Now please connect the wires to a switch, 3 switches. Please take 3 switches. 3 switches first. Switches then මෙතනින් ගන්න එක තමයි switch 3ක් ගන්න. 3 switches. Here switches. Okay, 1 switch, 2 switch, and 3 switches. Okay. This switch, okay, please drag. So you can use the select tool to keep it in the prop. Otherwise, it will continue to draw. Okay, you can keep it in here. Just delete it. Okay. So then the nodes you can like connect to this one. This one can be connected to this, and this one can be connected to this, and this one can be connected to this one, and this can be connected to this one. Okay, so please do the connection. You need wires, Pute. Wires on. Nikam beha wires on. Wires walintama connection. Okay, then you can draw from there to there. Okay, that one to the last one. Good. Yes, that should be connected to. Okay, now you can see you have 3 inputs, and let's connect a bulb also. LED bulb. No, that is 7 segment. That is not the one. That the green color one. After oscillator, you have the bulb. Above, little above, little above, little above in the screen. This one, let me show you in arrow. This is the bulb, right? Okay. Just take that LED and draw one LED, and please connect that LED using a wire. Okay. Now you can see AND gate behavior. So even though you have one AND gate or 2 AND gate or 3 AND gate, any number of AND gate, what is the logic of AND gate? Gayatri, what is the logic of AND gate?
If all inputs are 1, output also 1.
Yeah, if all the inputs are 1, output is 1. To see that, you have to actually execute. You have to run the simulation. So that can be done by using this play button in the toolbar. Okay, when you run the simulation, it will start running. Now you can turn on the switches. When you turn on all the switches only, the bulb will light up, because that is the AND gate behavior. If all are 1, it is 1. Okay, now you know how to do this, right? If one, let's lower this one. Let's close the second switch. And you can see if at least one is not working, then the output will not work, not be there. Because if AND gate will work, if and only if all inputs are 1, it will produce 1 over the bulb status. Okay. I think now you have an idea how to do this using logic, right? So let's move back. Right. Okay. So now how to draw in logic, we quickly discuss. You can do this, how to run and simulate also we did. And they have shown how to actually create diagram for NOT gate. Then how to create then the logic truth table. Truth table, actually, you know this, right? So what is the truth table for logic NOT? If this is 0, then the output is 1. If it is 1, then output will be 0, right? So you can actually write this. And if you need, you can write this. This is how you fill the truth table for NOT gate, because it will invert. 0 will be inverted to 1, 1 will be inverted to 0. This is how you write it. Okay, so let's move to the next one, Pute. Let's see whether I have some text boxes there. Then I can add that. No, I don't have any text boxes. No, if I had, I could add that to the particular case. Is it a text box? No, it's not. No text box are there, right? Okay, no worries. Oh, here, so let's copy one. Okay, so this is the NOT gate truth table. Paste it here. The NOT gate truth table is when you get 0, then the result will be 1. And when you output 1, input 1, the result will be 0. And that is the NOT gate behavior that will simply invert. Okay, so can you tell what will happen for OR gate? What is the OR gate? AND gate, sorry, AND gate behavior? Yes, what is AND gate behavior? I said, just said that. Me, thank you. Gayatri said that actually, not me. What is the AND gate behavior?
If all the inputs are 1, output will be 1.
The output is 1.
Yes, if all the inputs are 1, output is. So this is how you write inputs, Putte. So you have to interchange these values. That means you write like, first one you write, when you have 2 inputs, starting with 0, then the next one will be, sorry, you have to start with 0, and the next one will be 1. And then again you write 0. Sorry. Again you write 0. And the next level also you write 1. So this is how you write. This is how you fill the truth table. 0, 1, 0, 1. The A you have to write 0, 0, 1. You have to double the first one. B is 0, 1, 0, 1. A is 0, 0, 1. This is easy way of filling, right? ඉස්සරහට මේක ඕන වෙනවා. එහෙනම් මේක මතක තියාගන්න. 0 1 0 1 0 0 1 1. ඔක තමයි pattern එක. Then the output, you said, as you said, the output is when output generated when both are 0, this is 0. And here also, that is also 0, because you know, AND gate will output 1 if and only if all are 1. මෙතනත් දෙකම 1 නෙවෙයිනේ. එහෙනම් මෙතනත් 0. ඒ වගේම මේ last එක, you can see both are 1. Then the output is 1. Okay, this is how you fill the AND gate. Right? If both are 1, output is 1. If both are 1, output is 1. This is how you fill the AND gate. Okay, let's move to the next one. That is OR gate behavior. You know that. How to fill OR gate? Similar to this. 0, 1, 0, 1. Then 0, 0, 1. A and B, you can write like A and B are the inputs. What is the output of OR gate?
0, 1 equals 1.
0, 1 equals 1.
Sorry.
0 plus 1 equals 1.
No, that is not how you should explain. That is also
If both the input
Both input 0, the output also 0.
yes, if both inputs are 0, then the output, that is the easiest way, right? That adapt to that method. Why I'm telling, because when you're solving complex problems, you might get struck. එහෙම නැති වෙන්න නම් struck වෙන්න හිර වෙන්නේ නැතු උත්තර දෙන්න නම් අර මේ විදිහට මතක තියාගත්තම ලේසි පුතේ. AND gate එකේ ඔක්කොම එක නම් එකයිනේ. If all are 1, output is 1. ඒ වගේම OR gate එකෙත් ලේසියම මතක තියාගන්න විදිය තමයි if all are 0, if both are 0, then the output is 0, otherwise it's 1. That is the easy way of remembering. If both are 0, output is 0, otherwise it's 1. Because then you have to remember only one status. Okay, so let's proceed. And so there's another one. Now you can see 2 OR gates are connected to this. 2 OR gates are there, and 2 OR gates here, A, B are the 2 OR gates, and it is connected, and C is also there. So A, B is connected to OR gate, then again OR gate, finally a NOT gate. Okay, so this is how the output is generated. This is very important. Now you have 3 inputs. බලන්න 3 inputs. අර රටාව වැදගත් වෙන හැටි. Why that method is important? You can see when 3 inputs, it's interchanging this way, right? Here 0 1 C 1 වලට මම හරියට දාන්නම් ඈ. 0 1 0 1 0 1 0 1. You can see interchanging pattern. 0 1 0 1 0 1. Then the next one 0 0 1 1 0 0 1. The third one, 4 zeros, 4 ones. So that is how they secure the pattern. So if you write in the same pattern, it's very easy to fill this table. Right? First, last digit 0, 1, 0, 1, 0, 1, 0. The next digit 0, 0, 1, 1, 0, 0, 1. The next digit 4 zeros, 4 ones. 4 0, 4 1. Okay, so then, so since you have O gates here, then බලන්න මේක lazy කරන්න මේ වගේ එකක්. මේ output එක එන විදිය අපි බලමු හදලා. මෙතනට වෙනකන් තියෙන O gates නේ. O gates වල behavior මොකක්ද? What's the O gate behavior? A, B, C both are going through O gate and again through O gate. What is the O gate behavior, Pute?
If all the inputs are 0, the output is 0.
Yes. Are you using two microphones? So it's like echoing, right? You are joining using two devices, is it?
No, sir.
No, sir.
I don't know. So it's like echoing back. Okay. Right. Anyway, forget it. So since you have O gates, if all are 0, here A, B, C, tuname O gate, here also O gate, here also O gate. If all are 0, O gate will keep 0. Here A, B, C all are 0, O gate will return 0. O gate will keep 0. මේ ඔක්කොම බිඳුව නම් තමයි O gate එක බිඳුව කරන්නේ. මේ තුනම A, B, C තුනම බිඳුව නම් බිඳුවයි. එහෙම නැත්නම් එකයි. Otherwise it's 1. මෙතනත් 1 1 1 1 1 1 1. එහෙමනම් මේ අනිත් පැත්තට ලියලා තියෙන්නේ. Why it is inverted? So why they have right inverted way? It should be 0 and all ones though.
Not gate.
Then there's a not
The
gate.
not gate.
Yes, then there's a not gate. So this will come, but after that it will be inverted because of this not gate. That's why you wrote, that's why they have written this as 1 and all zeros. Understood? Okay.
Yes,
Okay.
sir.
Okay, let's do this for the next exercises, right? So let's go and see what's there. Okay, here you have given some examples. This is the last activity actually. After this workbook is over. You can see it's a very easy chapter. Once understood, right? If you cannot understand this in the beginning, the theory lesson will be difficult.
Excuse me, sir.
Yes.
Sir, my activity is different than that.
Others also get a different activity.
No, sir, like this.
Sir, the only problem is I don't have those cables.
Maybe some printing mistake, something like that. Okay, the first one. Okay, let's answer the first one, right? First answer, the pattern is 0 1 0 1 0 0 1 1. And before getting the final output, so let's before writing the final output here, so let's draw it in the circuit itself and apply it here. Okay, I'm going to write it here now, right? First is, you can see, so this is when this is 0 and when this is 0. If both are 0, what will happen?
Inverted as 1.
Yes, inverted
Pass
dash.
1.
If both are 1, what will be here?
Pass O gate.
Yes, it will pass O gate. It will come again 1. If that is 0, then after not gate, again it will be 0. Okay, we can fill this in the table, Pute. So now if both are 0, then the output is 0. Okay, let's go to the next one. The first one is 0. The next one is 1. The first one is 0, but this is 1. Then what will happen? 0 will be inverted to 1, 1 will be inverted to 0, right? 1 will be inverted to 0. But if it is 1 and 0, 1 or 0, right? 1 or 0, this will be 1 because O gate, if there's at least 1, then it will 1. If both are 0 only, it's 0. But 1 will be inverted back to 0, similar way. Therefore, the second one is also 0. What about the third one, Pute? Third one, කොහොමද එන්නේ? කියන්න බලන්න. Third one will be, the first one is, okay, let's erase this. In the third one, this is 1 here, A is 1 and B is 0. B is 0. Then 1 will be inverted to 0 and 0 will be inverted to 1. 0 or 1 will be 1 and 1 will be 0. 0 1 ගියොත් O gate එකෙන් එක 1 වෙනවා. A 1 එක not එකෙන් ගියාම ආයෙත් 0 වෙනවා. Therefore, for this one also the output is 0. Okay, the last one. So let's erase this one. And let's see what's going to be in the last one. Last one, both are 1. If both are 1, so this will be 0 and this is 0. If both are 0, OR gate will output 0. But if it is 0, NOT gate will invert back to 1.
1.
Therefore, here you will get 1. Actually speaking, you can see some similarity of this truth table with what? Which gate? This is equal to some other gate. What is that?
AND gate.
Yes, that is AND gate, because
AND
AND gate is the one which output 1 if both are 1. ඔක්කොම 1 නම් 1 දුන්නේ AND gate එකනේ. එතකොට මේ හදලා තියෙන සම්පූර්ණ මේ ඔක්කොම එකතු වෙලා හදපු gate එක. So this is similar to AND gate, right? So that is something special. This is similar to AND gate. You can just draw it if you want. This is similar to, wow, it's my bad drawing, sorry. Is it okay at least? Seems somewhat okay. This is similar to AND gate. Okay, let's do the second one now. Second one, how many inputs are there? This is input A.
3.
Yes, this is input B. And this is input C. 3 inputs. Right, if there are 3 inputs, how do we write the truth table, Pute? You know that. If there are 3 inputs, how to write that? Yes? You know how to write that? Tell me, what's the
What
method
is
of writing? Yes?
4 zeros.
0, 0, 0, 1, 1, 0, 1.
Here you can write 0, 1, 0, 1, 0, 1, 0, 1. Then 0, 0, 1, 1, 1, 1.
0 0 1 1.
Then
0 0 0 0 1 1 1 1.
0, 0, 0, 1, 1. Okay, so this is how you have to draw the truth table. Okay, let's fill that quickly. That is the method, right? If you have any doubts, please ask, because I can explain now itself, right? This is 0, 1, 0, 1. This is 0, 0, 1, 1. This is 4 zeros. Let's repeat. 0 1 0 1 0 1 0 1 double 0 double 1 double 0 double 1. Then 4 zeros, 4 ones. Okay, then the output. Second one, what is the gate? A and B will go through the AND gate, and then A and B AND gate එකෙන් යනවා කියන්නේ අපි දන්නවා යනකොටම දන්නවා අපි AND gate එකේ නම් මේ දෙකම එක නම් තමයි මෙයා එක වෙන්නේ කියලා. ඊට පස්සේ මේකත් AND gate එකක් නේද ආයෙත් අපි දන්නවා මේ දෙකම එක නම් තමයි මෙයා එක වෙන්නේ කියලා. හරි ඒකයි මම කිව්වේ that logic is very important. If both are 1, output will be 1. Then if both are 1, output will be 1. Then you know actually the result of this truth table. What is that? If A, B, C, all 3 are 1 only, the output is 1. Understood? If A, B, C, all 3 are 1, then the output is 1. Otherwise, it's 0. Here only it's 1, otherwise it's 0. So please draw in your book. You can use pencil maybe. And also if you have any doubt, please ask. Here also the same. Oh, sorry. Okay, if all are 1 only, because all are AND gate, if all 3 are 1 only, this is 1. Because we saw this in this one, make අපි දැක්ක දේනේ. Both are 1, this will be 1. මේකත් AND gate එකනේ. If both are 1, this will be 1. That means if A, B, C all are 1 only, so the final output will be 1. That is why we draw the truth table in the following manner. Okay, I want you to do the third one. Third one. And the fourth one. I'll give you 2 minutes. I'll give you 2 minutes. Okay, I'll give you 5 minutes. Do that alone. Third and fourth.